Guys, welcome to another episode of Cuda Education. Today I just want to do a quick video discussing frustum planes. Okay, so we know that in our application, I'll just run our application normally. We see that we have our objects and we basically, let's just zoom in a little bit, right? Or a lot, right? And then basically we have objects all around us, right? In front, behind, left, right, below, below, and above. Okay, so we have our objects all around. Okay, if we freeze the frustrum, right, we still have some stuff on the left, we still have some stuff on the right, but for the most part, up top is cut, below is cut. Far is the same and the front is the same. Okay, so and of course, if we unfreeze, we get back all our objects, right? Okay. But what I want to discuss and what the point of this video is that the frustrum is the viewing box of the camera, right? So we have the we have the far plane, the near plane, right? The top plane, right? The top plane, the bottom plane, right? The left plane and the right plane. Okay? So top, bottom, near, far, left and right. All right? We get that, right? And when we apply the frustrum, we're now testing against those realities, right? So the left and right, you can't really tell, but the top and the bottom, definitely. And even like, behind us is clear, right? So when we unfreeze, the behind us isn't thing because what have you, right? So all right, so what we want to do now is, we remember it's a mathematical equation that's testing against left plane, right plane, top plane, bottom plane, near plane, far plane. Okay, so what we want to do is we want to collapse. Instead of testing against 6 planes, we only test against 2 planes. Okay, so let us run our application again with only testing against 2 planes. And the mathematical discussion and equation for this was done in a previous video in the series. So let's just zoom in a little bit. All right, again, we haven't frozen it yet, so we're not discarding objects yet. So we have our top plane, our bottom plane, our left plane, our right plane, our far plane, and our near plane, right? And actually we have even behind us, right? Yeah, even behind us we have stuff, right? Right, even behind us we have stuff. It doesn't fully allow you to go behind. But now let us freeze, right? So top and bottom and all that, right? Let us freeze the planes, but freeze the frustrum, but now we're only testing against 2 planes. So we freeze it now, right? So some things should be discarded, okay? Top plane doesn't look like it's discarded. Nope. Top plane isn't discarded, hasn't discarded objects, right? So the top plane is still holding objects, right? Even though it's completely outside of our viewing frustrum, right? I guess you would call this what? This is a far plane, right? Left plane generally remains the same, and so the bottom, Okay, the far plane. But basically, guys, you could see that because we're testing against less planes, we now have we now have more objects that are being displayed. And we could actually check that by looking at the total number of objects. So right now we're at 19,666, right? Let us just do it. Let us just do it by default. So I'm not even gonna zoom or anything. I'm just gonna do it by default, right? So we're at 76,000 by default. If I freeze, no, well, I can't even do that by default. I need to do a standard way. So 1, 2, 4, 5. Oh no, that's not gonna work because this doesn't discard. No, the counter doesn't discard objects. Okay, but let us now go back to 6 planes, right? So now we're testing against 6 planes. I was hoping the stats would throw away, you know, it would update based on the number of objects, but that's not the case. So let's go to let's zoom in a little bit, right? And then, you know, we have everything as before, right? And we have all the way around, right? Okay. But when we freeze now, notice we get, well, this and this stays the same. Well, the top is cut off, the bottom is cut off, and then behind us is completely clean, okay? So I'll do it again. I'll juggle it again. So I'll just do the 2 again, right? Just to see what's going on. So now we're testing against 2 planes again. Let us zoom. All right, we'll do here. So we'll freeze. So the left and the right is pretty much what we expect. The top, right, that's the top, right? Yeah, the top is still there. The bottom is still there. Turn around, the behind disappears though, right? Which is probably, you know, and that's it, guys. So, you know, basically, you know, we're not going to get into detail about it, but the moral of the story is that 6 planes we're testing against, right? 6 planes, right? So again, we're talking about left plane, right plane, top plane, bottom plane, near plane, and far plane, right? Right? Left plane, right plane, top plane, bottom plane, near plane, and far plane. Okay? I was hoping this would update when you freeze a frustrum, but it doesn't. Okay? But anyway, guys, so that is the moral of this story. Okay? So again, guys, if you want to be able to run this stuff on your machine, you need tutorial number 1 and you need tutorial number 13. Tutorial number 1 is installing the Vulkan SDK on your Windows-based machine with a Vulkan-capable GPU. This example does not require ray tracing capabilities, but if you want to run the ray tracing examples, which are these down here, you're going to have to get a ray tracing capable card. For NVIDIA, that's RTX and above. For AMD and Intel, I have no clue. Okay. I would highly, yeah. So that's that. But we're testing against 6 planes. Okay, 6 planes. That is what we're testing against. It's basically a box. You could look up Frustrum planes. You could look up Frustrum planes online, and it will outline you the 6 planes: left plane, right plane, top plane, bottom plane, near plane, and far plane. All right. But guys, thank you for watching. Like and subscribe. Tell your friends. Work on computer graphics. Don't just don't just use it for video games and stuff. You could actually learn stuff. Everything is going digital. Get your creative juices going. If you know computer graphics, you could create magical things that the world can enjoy. Thank you guys for watching. Have a great day.